My name is Vincent Rolliard from Real Vibrations. Recently we've made some significant changes to our vibration shaker controller software, and I'm making this little video to help you get going with using the system. Right now I will log in the system as a system administrator, which is password restricted. And when you first get the system, it will come with a factory default which you will select. This will force you as the system administrator to set the maximum displacement of your shaker system. So currently we have a system connected to a 3-axis vibration shaker system, and I will set my displacement to say 40 millimeters, so that means a full stroke of 80 millimeters and an angular motion of plus or minus 10 degrees for the pitch and roll axes. And here it asks me to confirm what I've put in. These are very important parameters, and you should make sure that the data you enter is absolutely correct. So the system now loads the default configurations, and in the first instance, as you get a new system, the first thing to do is to set up a test and also calculate the shaker ID, or the system frequency response function. So I'll do that here, and the first thing I'll do is because it's a 3-axis system, I will check or verify all the important parameters for each of the axes. So this is a heave axis, and here this is important to get the units right and to get the sensor sensitivity right. Normally the software will be supplied with the correct sensor sensitivity depending on the information given to us by our customers. And here for the heave axis, which is controlled with an accelerometer, we will generate white noise over a bandwidth of 0 to 200 Hertz, and the shaker actuator maximum voltage, so the shaker will move full stroke if it's excited with plus or minus 10 volts, and here I'll divide by 5, so we're going to produce a voltage of about 2 volts to excite the system. So I'll enable the DOF, and essentially I'll do the same thing for pitch and roll. Because the pitch and roll axes are controlled in a displacement domain, we will use Brownian noise to excite the system. And here we have the same thing, a shaker actuator, maximum voltage 10, and we will produce a voltage of 2.5 volts. I will enable pitch and I will enable roll. The setup is the same. Okay, so now I can really proceed and measure the shaker ID. Currently what you see on the screen doesn't really matter to the shaker ID. This is simply a default spectrum here, the PSD on the bottom left. It's a constant RMS level of 2 meters per second squared, bottom right, and top right is the Gaussian distribution, which will be synthesized in this particular case. Now, I don't actually have a full shaker here. I have a simple cable system, if you like, but I will go through a process anyway. So I will go shaker. Here we can put an algorithm to smooth the FRF, which is useful, and the system will stop after 30 averages. And we will save identification signals. We can put yes here, but it will prompt us to save it anyway. So I'll go shaker and I'll run the shaker identification module. So what will happen now, the 3 excitation channels will be used to generate excitation, random noise, and the response of the 3 axes will be measured, and as you will see here, the FRF will be calculated. In our case, because we don't have an actual vibration test system, we will get a perfect straight line, if you like, through the FRF. And here you will see also we've got the system running at a frequency resolution of 0.1 Hertz, so it takes 10 seconds to get one record. So normally you would let that go for a good number of averages, or until the FRF no longer changes. But here, as this is a demonstration, I will stop it prematurely. So I'll stop, and it will ask me, do you want to save the result? Yes, I'll save the results. And that's it. That's all you have to do. and the system now will remember this shaker ID file. So now as a user, I want to generate a test. So let's say I want to set up configure a simple test using the ASTM track spectrum, which is already programmed in the system. And you can see this is spectrum, and you can see there's a whole range of power spectral density functions that are available here, which have been supplied with the system. It is easy enough to create these functions. And here I will run this test, say, at a particular level. So I will run it here. I've created an RMS distribution sheet, which is the heave will be 2 meters per second squared, the pitch will be half, and the roll will be half. You can see here as I switch axes, and you will see. So this is a simple stationary test, and the pitch spectrum also is defined, and the roll spectrum is defined. Note that the pitch and roll spectra are defined in displacement. And now all I have to do is set the time of my test. See if I want to do a test for 120 minutes, 2 hours. And really what I should do now is make sure that the test is can be done. So I can check the required shaker displacement, and that's fine. It will require a displacement well within my shaker limit, and it does so for the pitch and roll as well. Okay, and I will start the test here. So I'm starting the test to make sure that the system works correctly. So we'll assume that there's a multi-axis vibration test system connected to this controller right now. And now you see this after initialization of the system, and that can take a while, so do be patient, especially for multi-axis tests that are of significant durations. And now if I press yes, the 3 excitation signals are sent to the controller, to the vibration shaker table, I should say, and you will see the feedback signal for each axis, as you can see here for heave, and you will see the pitch and the roll. And now that we are satisfied that this test works well, we can actually stop it prematurely, because we are now configuring a test for possibly somebody else, like an operator, to use. We'll terminate this, and this is important. We will now save this test. So we'll then go File, Save. We save a single test configuration, and now we'll give it a name. So I'll give it, say, ASTM, heave, pitch, and roll, and I shall call it, say, 2, 0.5, 0.5, which are the RMS, constant RMS. So I'll give it a name that makes sense, and I'll save it. So I can do this again and again for all kinds of different tests. So next time the operator wants to run this test, all he or she has to do is log in through the operator login. Then he has to go, or he or she use load test. So we load test configuration. Here's a new test we've created. We select. It is important to note now the test has been validated and verified. And now we can simply press start. It asks the operator to accept the disclaimer. And here the system is initializing and will start as before. And here you can appreciate the difference, whereby the test configuration can be created by the system administrator and tested to make sure that they work correctly, and the operator can simply log in, load the test, and run.